Alright, this is a recording of the volatility example that I showed for you guys in the class. So as you can see, this is the unknown image, and I'm going to run volatility tool to do some analysis of this captured memory file. So -F is to point to the image file. So I have my files here, unknown image, and I'm going to run my PS list, which is one of the plugins that I walk you through in the class. The purpose of this is to essentially run through all the process that is currently running on this image as at the time it was captured. Remember, this is the offset here, and this is virtual offset, and this is the parent ID. This is the parent of this parent ID. This is thread handle, and of course you have the start over here. This is the date. So just keep this in mind. And then the next thing we did in the class was we went to go ahead and do PS scan, and the main difference between PS scan and PS list, like I told you in the class before, was number one, this gives you a physical memory offset here, and also we are actually looking more like a brute force alternative to PS list. One of the things that PS scan does for us is it bypasses the linked list and instead scan through the memory looking for the e-process data structure. The e-process data structure are something that are unique to processes, and by scanning for that data structure, we are most likely to be able to find processes that may be trying to hide, or that are already terminated but still lingers a little bit in the memory. So one quick look, if you're looking for the difference between what you have in this PS scan and the PS list that we ran up here, you might find it a little bit difficult to see whatever it is that may happens to be present in PS scan and is not in the PS list. Of course, whatever that is present in the PS scan and is not present in the PS list will be something that we'll find very suspicious, because that means it's trying to hide, and we might probably want to investigate into that a little bit later. However, this can be quite challenging because you have to flip back and forth, but never to worry, because we have an alternative, another plugin that allows you to view them in real-time mode. So you can go back and say X view here. So it's going to allow you to view the output of PS list and the PS scan side by side, and this I found it to be the most useful because now I have my PS list here, I have my PS scan, and it's easier for me to compare the output side by side. One of the things you're going to notice is that you are having a physical offset here. This works just fine now, but there are times when you might realize that you need to actually specify physical offset. In this case, not a problem here. So you could come over here and type a physical iPhone offset, and what that does for you is to ensure that the offset address is physical and not virtual. So if I press enter for this one, I would still get the same output. Oh, wait a minute here, just 1 second here. I hope I'm not doing something a mistake here. 1 second here. Gonna take a look at my command. So I have a physical offset. I'm missing letter O here. So as you can see here, It's essentially the same thing, but at least it's run this time around. So I can make sure I'm looking at the physical offset. Why is this important? This is important in case of the time when we would like to dump the content of a memory. That's going to be very, very important. Another thing that we would like to do in some cases, we might not be as lucky and discover the process trying to hide itself. We might look for sign of malicious activity. And where else would we want to go other than to look see if malware has opened up a network TCP connection, which we may be able to find that information from memory image as well. And really, one of the powerful tools that we can use is ConnScan and connections. One of the things we get with connection is it's very easy for us by running these plugins to find TCP connection, and each one goes and find them using different techniques. In our case over here, we're going to look for this process. Remember here, PSList said it's not there, but PSCan says it's there. So by running the plugin connection here, I will see all the connections that were made at the time this image was taken. In this case, there's only one connection. However, if I run ConnScan, what ConnScan would do for me is that ConnScan will look into the memory, and that it might be able to find even connections that were closed prior to memory image being acquired. So since processes doesn't immediately clear or overwrite in the memory, it is still very possible for you to see memory that has been connection that has been made in the past and that has been disconnected. It's still there in the memory because it has not been overwritten. So this is a very good opportunity for you to kind of go back in the past, and you can see there's only one connection we have in this case. So this is very, very good indication. As you can see, now you can begin to tie the evidence. Here is a process trying to hide, and when we run connection, we can see that it is this same connection that was making a remote connection to a remote host. So the next thing that we might probably want to look at over here is the sockets and socket scan. Sometimes we might want to know if the malware has not opened up a connection yet, but instead the malware has set up a backdoor waiting for an incoming connection from an attacker. So in that case, so then I can come back over here and say sockets, okay, and just press enter, and here I can see all the open ports. Now I will be looking here to see if I see any port from a strange maybe address that might be a little suspicious to me. Another thing that I could also look at, so the next thing I'm going to do here is to go and run the counterpart, just like we have ConnScan for connections. There's also we have sock scan. Again, it would also go ahead and look for a listener that had occurred in the past that may now be closed. Now we have gone over a couple of series of plugins that I think are very useful. I'm going to go back to this PXS view, however, because we're going to try to see if we can actually in fact dump a process into our hard drive, because we might want to actually examine and analyze that particular process. We know that any application or even malware, when they are running in memory, they are running in plain text. So it's a good opportunity for us to dump them from memory and then be able to analyze those processes. So, in case you probably might be wondering, how do I know what command? What if I forget any of the command? It's very, 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 easy here. If you type -H here, you could look at all the plugins you have for volatility tools, and I can easily go down here and I can look for proc dump. Okay, and even if you don't know how proc dump work, you can potentially come over here and type proc dump. I'm going to pretend I don't know this, and I'm going to show you how you can easily find out what are your options. So if I press this guy is going to say, well, you need to specify your directory. Okay, fine, I'm going to do this. And then if I come over here and press space and do this, and I can specify my home directory, and I say put it on Ubuntu. Then if I do this, one of the things you're going to do is, if I just go ahead and dump this, it will dump all the process on this image for me. That's not what I want. In order for me to specify the particular image I want, then I need to specify the address, and this time around, remember, you need to use a physical address. If you do not use a physical address, you're going to get it wrong. So then how do I go about specifying the address that I want? Here's the next option we're going to go. So this is what I would type, but then I need to know the address of what I want to really go after. One of the things I try to do is I need to specify my offset address. I want to make sure the offset address specified here is a physical address. So this is what we were looking for, this guy here. So I'm going to grab this guy. Again, remember, this is a physical offset. So a virtual offset will not work because it will not map to the actual physical address location. So I specify this. Then I would say I ran volatility against the image over here, and I said dump the process. This dump directory on my home directory, and I'm specifying the offset to go after. So if I do this, so you can see now it's already dumped this process as actual 560, and that is the 560 over here is the actual address that I want to go after. This is very, 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 very important. This is very, very important. Now you can see how nice and easy we have it now. One other stuff that I show you in class is we can run string through against some of these files just to kind of do some temporary work on it. I just want to find out what do I have here. And one of the things I did for you guys in the class is I can run this through egrep, okay, and I can specify not to be case sensitive. And for this one, I can quickly say look for join, or a pipe means or. I can say nick, and I can say pass. These are keywords, especially if I think that this thing is being used in conjunction with IRC channel and so on and so forth. And they can see there's a couple of match here. I have nick, join, dollar, and so on and so forth. I can modify this a little bit, especially if I think that a remote network is being accessed. So I can go over, run this one through HTTP, run it through pipe, and go for system 32. In this case, if I press enter here, now you can see that I have a lot of return. Again, it's passing through this executable, and this egrep allows us to be passed through even binary files. You can see there's a lot of link here. These are vital information that will allow me to kind of see what are the artifacts that I can get from this system right away. And you can see this WMIT CDC right away here. That's very important for us to quickly take a look at that and analyze that. Another thing that you could also look for that are, generally they are recommended searches, because this is Windows. I can look for executable files, and one way to do that, you can just use period, and then say .exe, and when you do press enter here, you could find quite a lot of potential executables, rootkit 2 potentially, that are present inside this particular file that we're investigating. You can see tempdev.exe, coinme.exe, this is a file over here, virus utilities.exe, antivirus install, then you could probably unlock her. So right away, virus.exe, you could tell that this file is definitely malicious just by looking through and parsing through these dump executables. This is very important, especially as we navigate the content of this file. So this is what we did last week, and this is where I'm going to stop here. Hope you enjoyed this video. Take some time and go over this yourself. Make sure you can do this. If you have any question, please send me an email. Thank you.